Welcome to Unit 2, Lesson 3, Solving Radical Equations Graphically. By the end of this, you should be able to relate the roots of radical equations and their x-intercepts, and then determine approximate solutions of radical equations graphically. So we'll just start right in with an example. It's all skills that you're familiar with already. So the first example is relate roots and x-intercepts. So determine the roots of x plus 5 minus 3. Now, when we say roots, we're talking about x-intercepts of a graph. So that should help you keep in mind that you're trying to hit this line right here to find the intercept if you're just drawing the equation exactly as it's given. Now, we're going to figure out two different ways to solve the graphs. One is graphically and one is algebraically. I know you're probably shaking in your boots hearing the word algebra, but just be brave about it. It's just a few simple steps and we'll figure it out together. So to determine the roots of x plus 5 minus 3, now we know that if we make our mapping points of that function, we have x minus 5, y minus 3 for our points. So you take that square root graph that goes from 0, 0, 1, 1, 4, 2, 9, 3, and you make your horizontal and vertical shifts, left 5, down 3. Now I solved it graphically in the middle for you right here to explain it, but it's up here as well, so whichever side you like. So we have this function and we know that this means y equals x plus 5 minus 3. So when we want to know when y equals 0, what does y equal? What does x equal? So first step, move the 3 over to the right hand side by adding 3 to both sides. Now we have root x plus 5 equals 3. We want to get the rid of the square root, so we're going to square both sides. Root x plus 5 squared equals 3 squared. I lost my whiteout, so I just repeated this step, but it's exactly the same as above because I had already drawn the square root symbol. Okay, so we're just squaring both sides. The square root goes away. X plus 5 equals 9. And then you're moving the 5 to the right hand side by subtracting 5 from both sides. 9 minus 5, x equals 4. So what this tells us is when y is 0, x should equal 4. Now, what we can also do is a second method, which is shown on the right here. And what we do is say, set the equation equal to each other. And what we can say here is that the root of x plus 5, which is one graph, is equal to x equals 3. And that's going to give us our y coordinates. The first graph is y1 equals 3. That's here, this horizontal line that's going across the graph. And y2 is root x of plus 5, which is a shift to the left 5 units. So 1, 2, 3, 4, 5 from the origin. Now, when we say that these two equations are equal to each other, that's important because what that means is it's going to show us exactly where that graph will intercept. And if you notice that in this equation, our graph intercepts at 4 for an x value, 0. Now this equation, we don't have that vertical shift because we've said that the x-intercept is equal to that vertical shift. So in this graph here on the right, we still have our x-intercept where the graphs are intercepting at 4. And then of course we're up 3. We can also have a situation where one of the solutions for x will not work. It will give you two equations that are not equal to each other. So on this side, we have a little bit of a different equation. We have the root of plus 5 equals x plus 3. And we want to solve it algebraically and graphically. And I'm going to show you how to do both ways. If you're not familiar with polynomials, which is this term right here, x squared plus x plus 9, if you haven't seen these in a long while or you need a refresher, I'm going to recommend that you go to these two videos and check out multiplying polynomials, the FOIL method, and math algebra, how to factor them. The reason being, this is some prior knowledge that you're supposed to have, but if you haven't taken 10 and 11, then you might be missing it. So it's really simple to figure out. Just follow the video and really commit to learning how to do this, because it will make your pre-calculus life easier. So anyway, we solve these two by setting them equal to each other. Now what needs to happen in this solution for us to figure out what x is that we have to have y equals to 0, okay? Now, how we create that 0 is by moving everything over to one side or the other. Typically, you want to pick the side that's going to give you positive values. Now, in this line here, we have x plus 3 squared. You'll see in these videos about FOIL, what this means is x plus 3 times x plus 3. Okay, and to get these values, you follow the FOIL method. F stands for first. X times x is x squared. Inside and outside. So inside, 3 times x, which is 3x. And then another 3 times x for outside, which is another 3x. Excuse me, x. That doesn't look like an x at all. Another 3x. And when you add these two together, you get this middle term, 6x. And the last step, L, stands for last, and that's 3 times 3, which gives you 9. Okay. Now that all our terms are in x factor format, what we can do is move everything to one side of the equation. Now you typically want to move things where it's going to give you a positive x squared value, so that you don't have to worry about dividing all your terms by -1 to get rid of that negative symbol. So kind of wherever the greater x squared value is, move things that way and then work from there. So we subtract x from both sides. We now have 5 x's left. And we also subtract 5 from both sides. And now we have 9 minus 5, 4 left. We didn't do anything with the x squared term, but you need to leave it there. So now we can do x squared plus 5x plus 4. And then we need to factor it and get back to this binomial format, so that we're able to see what x can possibly equal. And if you're not sure how to do this and get back to this, you want to check out this math algebra, how to factor polynomial with special method. It will really help you out and give you some easy tips to be able to solve this. So when we get back to this format, we get x plus 4 or x plus 1. And if we set those equal to 0, we'll say x plus 4 equals 0, x equals -4. And then this one, I didn't do the work, but x equals -1. You want to think, what makes this 0? So once you've done that, we're able to decide what x can equal. Now, sometimes it can equal both if there's 2 x-intercepts, but a lot of times what will happen is that you'll take these values of x that you found, -4 and -1, and plug them into each side of your equation. And one of them is going to give you an inequality. So for example, if we say x is equal to -4, on this side it's the root of 1, which is 1. And on this side it's -4 plus 3, which is -1. These are not equal numbers. So we know that x cannot equal -4. If we compare using -1, we plug -1 into these values, we get x plus 5 minus 1 plus 5, root of 4, which is 2, and then a -1 plus 3, which is also 2. The left side equals the right side, so we know that the answer is -1. You could be asked to solve a problem like this, so make sure you know how to do this and ask questions if you're uncertain. I will gladly go over it. Now, what we can do is make those two y equations again, representing each of our graphs to determine the intercept of x. Now, what you do is you just say one of the functions is equal to the left-hand side, the other is equal to the right-hand side, and you'll see that they cross there at -1, 2, which is exactly what we proved up here. Beyond this, you have a couple questions for practice. I highly recommend you watch those 2 videos. I'm going to add the link in the post, and please prepare yourself for class tomorrow.